NEC Section 210.7 done addresses switches on alternating current general use branch circuits. This section specifically states that each switch shall control only the load supplied by the branch circuit of which it is a part. The interpretation of this code is that a single 2-pole snap switch cannot be used to control two separate circuits that are fed from different circuit breakers. The primary reason for this restriction is safety. If the circuit breaker for one of the circuits is turned off, one side of the switch will remain energized. This creates a potential electrical hazard for anyone who might come into contact with the switch or the wiring connected to it. The code is designed to prevent situations where a device appears to be de-energized because one circuit is off, but is actually still live and capable of delivering an electrical shock. When working with electrical systems, understanding and adhering to the National Electrical Code is crucial to ensuring safety and preventing electrical hazards. This code provides guidelines for safe electrical installations, protecting both individuals and property. Considering scenarios where multiple circuits need to be controlled from a single location, the NEC provides alternatives that maintain safety and code compliance. Firstly, consider using a 2-gang box. Install 2 separate switches within this box. Each switch can then control one of the circuits independently. This approach ensures that each switch only controls the load supplied by its own branch circuit. It adheres strictly to NEC Section 210.7 done. Secondly, explore the use of a relay. A relay can be used to control one circuit, such as a fan circuit, based on the state of another circuit, like the light circuit. In this configuration, the light switch would control the relay. The relay would then switch the fan circuit on or off, depending on whether the light switch is on or off. This approach can provide the desired control functionality while maintaining separation between the circuits and ensuring compliance with the NEC. It is always important to label switches and circuit breakers clearly. Proper labeling ensures that individuals can easily identify which switch controls which circuit. This is particularly important when multiple circuits are present in the same area or when circuits are controlled from different locations. Clear labeling can prevent confusion and reduce the risk of accidental electrical shock. When implementing electrical installations, always consult the latest version of the National Electrical Code and any applicable local codes. Electrical codes can vary depending on the jurisdiction. Consulting with a qualified electrician or electrical inspector is recommended to ensure that your installation meets all applicable requirements. This helps ensure compliance and safety. Consider the impact of using a 2-pole switch when only one pole is intended to be used. While it may seem harmless, it can create confusion during maintenance or troubleshooting. If someone assumes that both poles are active and energizes only one circuit, they could inadvertently create a hazardous situation. It is best practice to use switches that are appropriately rated and designed for the intended application. If a single-pole switch is sufficient, use a single-pole switch. Avoid using components in a way that deviates from their intended purpose, as this can compromise safety and reliability. When troubleshooting electrical issues, always follow proper lockout-tagout procedures. These procedures involve disconnecting the power source, locking the disconnecting means, and tagging it to indicate that the circuit is being worked on. This helps prevent accidental energization of the circuit while work is being performed. Lockout-tagout procedures are essential for protecting workers from electrical hazards. It is critical to understand that electrical codes are not static. They are updated periodically to reflect new technologies, best practices, and safety concerns. Staying up to date with the latest code requirements is essential for electrical professionals and anyone working with electrical systems. Code updates can impact the way electrical installations are designed, installed, and maintained. Ignoring these updates can lead to non-compliance and increased risk of electrical hazards. Consider the specific application when selecting electrical components. Factors such as voltage, current, environmental conditions, and intended use should all be taken into account. Using components that are not rated for the intended application can result in premature failure, electrical hazards, and non-compliance with codes and standards. Always consult product documentation and seek expert advice when selecting electrical components for a particular application. Consider the potential for future modifications or additions to the electrical system. It is often wise to design the system with some extra capacity to accommodate future needs. This can avoid the need for costly and disruptive upgrades later on. When planning for future expansion, consider factors such as increased power demand, additional circuits, and new equipment. It is always better to over-engineer the system slightly than to under-engineer it. When routing electrical wiring, pay attention to potential sources of damage or interference. Avoid routing wiring near heat sources, sharp edges, or areas where it could be subject to physical stress. Use appropriate conduit or other protective measures to protect wiring from damage. Proper wiring practices can prevent insulation breakdown, short circuits, and other electrical hazards. When making electrical connections, use proper techniques and tools. Ensure that connections are tight, secure, and properly insulated. Loose or poorly made connections can create resistance, which can lead to heat buildup, voltage drops, and potential fires. Always follow manufacturer instructions and use appropriate connectors and crimping tools when making electrical connections. When working with electrical systems, it is important to be aware of the potential for arc flash. Arc flash is a dangerous phenomenon that can occur when a short circuit or other fault causes a sudden release of electrical energy. Arc flash can cause severe burns, blindness, and even death. Electrical workers should always wear appropriate personal protective equipment, such as arc-rated clothing and face shields, when working on or near energized electrical equipment. Consider the use of ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electrical shock. GFCIs are designed to detect small imbalances in current flow, which can indicate a ground fault. When a ground fault is detected, the GFCI trips the circuit, interrupting the flow of electricity and preventing electrical shock. GFCIs are commonly used in bathrooms, kitchens, and other wet locations. Ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Grounding also helps to reduce electrical noise and improve the performance of sensitive electronic equipment. Proper grounding is an essential safety measure in all electrical systems. Consider the use of surge protectors to protect electronic equipment from voltage spikes. Voltage spikes can be caused by lightning strikes, power surges, or other electrical disturbances. Surge protectors divert excess voltage away from the equipment, preventing damage. Surge protectors are available in a variety of types and sizes, and should be selected based on the specific needs of the application. When performing electrical work, always disconnect the power before starting. This is the most important safety precaution that can be taken. Verify that the power is off by using a voltage tester. Never assume that the power is off, even if the circuit breaker is switched off. Always test the circuit to ensure that it is energized before starting work. When working on electrical systems, it is important to be aware of the potential for static electricity. Static electricity can build up on clothing, tools, and other objects, and can discharge when they come into contact with electronic components. Static electricity can damage sensitive electronic components, such as integrated circuits. To prevent static damage, use anti-static mats, wrist straps, and other grounding devices. When disposing of electrical equipment, follow proper recycling procedures. Electrical equipment contains hazardous materials, such as lead, mercury, and cadmium, which can pollute the environment if they are not disposed of properly. Contact your local recycling center for information on how to properly dispose of electrical equipment. When selecting electrical wiring, choose the correct wire size and type for the application. Wire size is determined by the amount of current the wire will carry. Wire type is determined by the environment in which the wire will be used. Using the wrong wire size or type can result in overheating, voltage drops, and potential fires. Always consult the National Electrical Code and other applicable standards when selecting electrical wiring. Consider the use of arc fault circuit interrupters or SIs. SIs are designed to detect arcing faults, which can be a sign of damaged or deteriorated wiring. Arcing faults can cause fires, and SIs are designed to trip the circuit before a fire can start. SIs are required in many areas of the home, such as bedrooms and living rooms. Ensure that all electrical panels are properly labeled and organized. A well-organized electrical panel makes it easier to identify and troubleshoot electrical problems. Label each circuit breaker with the name of the circuit that it controls. Keep the panel clean and free of obstructions. A well-organized electrical panel is a sign of a professional electrical installation. Consider the use of occupancy sensors to control lighting in areas that are not always occupied. Occupancy sensors turn lights on when someone enters the area and turn them off when the area is vacant. Occupancy sensors can save energy and reduce lighting costs. They are commonly used in offices, hallways, and restrooms. Ensure that all electrical work is performed by qualified and licensed electricians. Electrical work can be dangerous if it is not performed properly. Qualified electricians have the training, experience, and knowledge to perform electrical work safely and in accordance with applicable codes and standards. Hiring a qualified electrician is an investment in safety and peace of mind. Consider the use of uninterruptible power supplies or UPSs to protect critical equipment from power outages. UPS provide backup power in the event of a power outage, allowing equipment to continue operating until the power is restored or the equipment can be shut down safely. UPS are commonly used to protect computers, servers, and other critical electronic equipment. When inspecting electrical systems, look for signs of damage or deterioration. These signs can include cracked or broken insulation, loose connections, corroded terminals, and overheated components. Any signs of damage or deterioration should be addressed promptly to prevent electrical hazards. Consider the use of energy-efficient lighting, such as LED lights. LED lights use significantly less energy than traditional incandescent or fluorescent lights. LED lights also last much longer, which reduces maintenance costs. Replacing traditional lights with LED lights can save energy and money. Always follow manufacturer instructions when installing electrical equipment. Manufacturer instructions provide important information about the proper installation and operation of the equipment. Following these instructions can help prevent damage to the equipment and ensure that it operates safely and efficiently. Consider the use of tamper-resistant receptacles, or TRRs, in areas where children are present. TRR have a built-in safety mechanism that prevents children from inserting objects into the receptacle. TRR are required in many areas of the home, such as bedrooms and playrooms. When working with high-voltage equipment, take extra precautions to prevent electrical shock. High-voltage equipment can be lethal. Always wear appropriate personal protective equipment, such as rubber gloves and insulated tools. Work with a partner whenever possible. Follow all applicable safety procedures. When troubleshooting electrical problems, start by checking the simplest things first. Check the circuit breaker, the switch, and the wiring connections. Often, the problem can be traced to a simple cause. Avoid making assumptions and follow a systematic approach to troubleshooting. Consider the use of smart home technology to control and monitor electrical systems. Smart home technology allows you to control lights, appliances, and other electrical devices remotely using a smartphone or other device. Smart home technology can save energy, improve security, and make your home more convenient. Ensure that all electrical systems are inspected and maintained regularly. Regular inspections and maintenance can help to identify and correct potential problems before they become serious hazards. Schedule regular inspections with a qualified electrician. Consider the use of renewable energy sources, such as solar panels or wind turbines, to generate electricity. Renewable energy sources can reduce your reliance on fossil fuels and save you money on your electricity bill. However, renewable energy systems can be complex and require careful planning and installation. Always consult with a qualified professional before installing a renewable energy system. When selecting electrical equipment, choose products that are certified by a recognized testing laboratory, such as Underwriters Laboratories, or all. Certification by a testing laboratory indicates that the product has been tested and meets applicable safety standards. Look for the UL listing mark on the product. Consider the use of variable frequency drives, or VFDs, to control the speed of electric motors. VFD can save energy by reducing the speed of the motor when it is not needed to run at full speed. VFD are commonly used to control pumps, fans, and other motor-driven equipment. When working with electrical drawings, be sure to understand the symbols and notations used. Electrical drawings use a standardized set of symbols to represent different electrical components and wiring connections. Understanding these symbols is essential for interpreting the drawings and performing electrical work correctly. Consider the use of power quality meters to monitor the quality of the electrical power in your facility. Power quality meters can measure voltage, current, frequency, and other parameters, and can help to identify power quality problems such as voltage sags, swells, and harmonics. Power quality problems can damage equipment and disrupt operations. Ensure that all electrical equipment is properly ventilated. Overheating can damage electrical equipment and create a fire hazard. Provide adequate ventilation to allow heat to escape from the equipment. Avoid blocking ventilation openings. Consider the use of infrared thermography to inspect electrical equipment for hot spots. Infrared thermography uses a special camera to detect heat patterns. Hot spots can indicate loose connections, overloaded circuits, or other problems. Infrared thermography is a valuable tool for preventative maintenance. When working with electrical equipment in hazardous locations, such as areas where flammable gases or vapors are present, use equipment that is specifically rated for those locations. Hazardous location equipment is designed to prevent ignition of the flammable materials. Follow all applicable codes and standards for hazardous locations. Consider the use of energy management systems to monitor and control energy consumption in your facility. Energy management systems can track energy usage, identify areas where energy is being wasted, and automate energy-saving measures. Energy management systems can help to reduce energy costs and improve sustainability. Ensure that all electrical systems are properly documented. Documentation should include electrical drawings, equipment specifications, and maintenance records. Proper documentation is essential for troubleshooting, maintenance, and future modifications.